and it can be paired with HP and entropy that I have already explained. To assign the weightage to the criteria, you may use the directive weighting method using stakeholder group, decision maker group, or you can use the HP and entropy method to find the weightage of criteria. However, there will be limitations. What are the limitations? Sensitive to weights, that means the weights of the criteria. It can change the entire result. If you just change the weightage of the criteria, the result will change. And it assumes a monotonic and comparable inputs. Okay, and there is a risk of rank reversal on set changes. And the criteria is correlated because the decision maker is giving the weightage, so it can distort results. And this is a very common problem for compensatory method. This problem is observed in case of HP also. The weak scores can be easily masked or overlapped. This term overlapped is more ideal. When there is a weak score, uh, it can be overlapped or masked by the higher, strong score of the alternatives. So this is an issue. Now, but the major problem is the decision is overly sensitive towards the weights and also towards the normalization. That is the major limitation. Now, where is it applied? It is applied everywhere: engineering design, manufacturing, supplier selection, spatial site suitability analysis, water sector, environmental sector, energy planning sector. Everywhere it is applied. Wherever decision making is applied, this is applied. So with this, I will conclude the TOPSIS tutorial or lecture note, whatever you say. Majority, this TOPSIS is 6-step process. So first step is uh, decision matrix. I have shown you how to make the decision matrix. Then normalized decision matrix. Then weighted normalized decision matrix. Then you go for PIS and NIS. Then you go for the D, right? D plus, D minus. And lastly, you go for closeness coefficient, C. So this C actually gives the solution. Which one is the best? So this is a very little bit simple and computationally efficient method, but it is sensitive to the weightage. While calculating this weighted normalized decision matrix, bias come into play if you use only the direct weighting method using stakeholder group or decision making group. Biasness means if you change the decision makers, the decision weightage may change, which will impact the decision. Okay, so main limitation is this, and there are many other limitations. Among those, comparable inputs is there, risk of rank reversal is there, correlated criteria, and also the common limitation of all the compensatory methods, compensatory MCDM methods overlapping. This error is here also because weak scores can be easily masked or overlapped by strong scores. That is the danger of it. Means money weak score means just reject. So that is not the case always, because sometimes the alternative with weak score can also be considered. You cannot say, right? When all are best, so there it will give weak score to some. Suppose you are selecting the best player, so Lionel Messi, Cristiano Ronaldo, and if you find anyone like which one to take, Messi, Ronaldo, and Neymar. Okay, so if we compare these three players, They are more or less have the same capacity, capability, skills, intuition, everything. They're more or less what we say as more or less similar importance. But if you use this method to select the best one out of them, you see one of them will receive a very weak score, right? So it will seems that he's not a very bad player compared to the selected player, but it is not the case in reality. So this limitation is there, and this limitation is there in most of the compensatory methods, but compensatory MCDM methods. Okay, so with this I will close, and always remember Boipatra VSC, my newsletter. It holds all the tutorials on MCDM, on nature-based optimization technique, on GIS, on AI and ML, etc. So you can go to Boipatra VSC newsletter or the site also. Okay, and of course remember to like my video, share my video if you really like this video, if you have any benefit out of this video. This will only encourages me to make more such videos. Okay, so goodbye for now and see you at the next video. Thank you.